Welcome to In a Nutshell, the podcast dedicated to all things agricultural consulting. I'm Dylan Brush here with soil genius and ag consultant Bill Brush, and we're delighted to accompany you on this journey where we break down the different aspects of agricultural consulting. In each episode, we'll dive into the realm of agriculture through the eyes of Bill Brush, where consultants like Bill play a vital role in empowering farmers, agribusiness, and agricultural organizations. If you're passionate about agriculture, problem solving, and enjoy a little bit of detective work, this podcast is tailor-made for you.
Welcome back, and this is Bill Brush with another episode of In a Nutshell. Today, I want to talk about a general topic and give you an insight into the current things that agriculture is doing, particularly in the idea of mechanization. Anybody that knows farming knows it's hard work, and a lot of it can be very backbreaking type of work. So finding enough people to do all the work, we used to be, lots and lots of laborers, but that's cut down with the advent of mechanization. Well, now this mechanization, we're doing a lot of things that take the kind of the thought process out, and our mechanization can be so that we can check things that are going on to our field that before would be time consuming. And things like we need to check and see where the water is, how, what's the depth of water, how much moisture do we have in the ground, and when should I irrigate? What are the temperature's going to be? What's the evapotranspiration rate? And all these are thrown into Big Hopper, and you figure out, I need to put this much water on this week, and here's the days I'm going to do it, and the length of time I'm going to run. Well, now, if you've got large acreage, you've got multiple areas, whether they be pump sites or they're off canals or whatever, and they have to literally open those up, set them so they know how much water, turn on their what we call booster pumps, which takes low pressure water, makes it a high pressure water, so it can run your sprinklers or drip or whatever type of irrigation system you might have it tied into. And now, because you have, a lot of these farms are spread out, you will be getting information on your phone, on your iPad, on your computer to do your water scheduling. Pretty soon you've got what we call water saving technologies, where we're trying to get the maximum amount of air and water for the maximum amount of time. So we're using the technology that we find through this to make the best and most efficient use of water. In a lot of cases, you may be using the same amount of water that you've used in the past, but now you're using that same amount of water to actually increase your production, because you're hitting all of those notes right at the same time they should be hit. We're getting water, and not too much and not enough, because when we're talking about irrigation, I like to tell growers all the time, but a plant looks the same when it doesn't have enough water or when it has too much. I call it water stress, but it can be stress from not having enough and having to pull harder trying to get what little moisture is left in the ground, using a lot of energy to take it up, or it's too wet, which means everything is saturated, and until things start to dry out and change the moisture gradient between the inside the root and the outside, it won't take anything up. So they look the same because they aren't getting the right amount of water. So everything we're doing with a lot of this new technology is trying to find that sweet spot of getting just enough water but not too much. And then you have to weigh the labor intensity that it takes to try to hit that target. Also, what type of ground do you have? Do you have a light sandy soil, which the water just pours through because there's lots of pore space and not a lot of clay to hold on to it and basically make it infiltrate, move sideways rather than just penetrate and just go right through? These all enter into this mechanization and understanding your soil so that you can use a lot of the technology for improvement on efficiency of water. You can be more efficient using less. You can be more efficient, like getting more crop. The term that we like to use, you're getting more crop for every drop. So getting the water to give you more yield by putting the same amount, or maybe slightly more, maybe slightly less. At the end of the day, it's about yield, because that's what feed people. And so we have to know exactly how much water it's going to take to get our maximum yield. Then, do we have that amount of water available? And if not, how do we parcel it out so that we can get the best out of the water that we do have? But the water, and we're seeing more, probably more innovation coming into water technology than anything that we find out there. We find ways to products to put on to keep our lines clean, so that our irrigation system is more efficient in that it doesn't plug. You have emitters, on a drip line. It takes so many pounds of pressure before it'll begin to drip out. And then it drips out so much per hour. Okay. And it's all measured, and the orifice and the actual emitter itself is all calibrated. Well, then we put in our irrigation water into that equation, and all of a sudden, the next thing we find out is it's not putting out what it says it should put out. And a lot of it is because of the impurities, the hard waters that we use. It could be we don't have a good enough filtration system. We need all of these things to working at top efficiency to get the top performance out of our irrigation system. So we'll have a product that we can dribble in at part per million, or very little amount, to be able to keep those lines open so that the irrigation is as efficient as it was designed to be. It's kind of odd when we have tree crops. One of the things I find it interesting is, when we first put out our trees, we put in a new irrigation system with them, and everything's perfect. Brand new system, small trees, everything's going along perfectly because it's right out of the box, ready to go. There might be a few hiccups in getting it just right, but once we're there, it seems like you don't do a whole lot. And on small trees, you don't use it near as often because you don't need near as much water, and you have it more concentrated to right around the tree. Anyway, as time goes on, we don't pay near enough attention to making sure the irrigation system works as designed. When now the trees are bigger, they need every drop of water that we're putting out there to be utilized for the crop that we're trying to produce. A lot of tree crops in the first 3 to 4 years, we don't have a crop, so it's very easy to irrigate with an absolutely perfect system. Then when we have the bigger crops, we have an older system that's not working at maximum efficiency. So one of the things I coach some of my clients and farmers to do is always keep working on that irrigation efficiency, because the better we can get that, the better chance you're going to have those maximum yields. If you can imagine, if trees are people, and we look down there and we have 10 that look really good, and the 11th one down there looks like he's dying, because he's not getting any water. People are just like these trees. If it's not getting water, you are supplying. And I always say it's a very interesting way, I guess I phrase it. I always tell people, what's the difference between plants and animals? One of the major differences. And I get lots and lots of answers. I said, one of the most important differences is plants can't move, and they're dependent on you or their environment to supply everything they need. As an animal, we come from, people come from nomads. They traveled all over. We don't have enough water here, we'll move over there. We don't have enough good soil here, we'll move over here. We move around to get what we need to survive. If you've ever looked at, the old days of herds of buffaloes going out, they travel from one area to another. They would eat here until they were out, or it got too hot, or the water got short, and they would move along all of their journeys to go to the multiple places to get the proper things. The crops themselves, they're pretty much stuck there. And so when you see that, and you don't irrigate all the trees to the best you can, I said some things are going to suffer, and you eventually make them weaker. That, or they just die if nobody's paying attention to them. So you need lots and lots of effort put into that irrigation efficiency. we can get all the technology perfect, but if we don't get down to kind of the nuts and bolts level, and is it working as designed, and are we meeting all the demands that we are trying to do? We also see that one of the other technologies that we're finding is a lot of our tillage equipment where we're working soils out here, getting them prepared for the next crop. That one tractor is pulling one implement, but that implement might be running a little bit of a disc, might be running a little bit of a float, and it might be running like a harrow. All of these pieces of equipment basically across on one pass. And then we have it ready for probably the next one. If you were doing vegetables, the next guy would come up, put up your beds, and you're ready to harvest. One pass where they would normally run a disc and then come back, maybe run a chisel, but you would just have 2 or 3 or 4 passes, which we're trying to accomplish that all with one pass. A lot of the stuff that we see back in the Midwest, a lot of it's what we call, no-till, where we do very, very little tillage to the topsoil, just enough to get down to where we can put the seed placement where we want to on the row area that we want, and probably put in some starter fertilizer, and we're ready to go. And some of the things we find through, not as much technology, but as proof, we run trials, we proof it out that if we don't till, we actually have less compaction. We have more protection of the soil from a lot of the stalks of previous crop. And so what we're looking at, and this has been going on for quite some time back in the Midwest, is that it'll hold, with that extra carbon material, it'll hold more water. If you're on just a strict rainfall irrigation schedule, that's all you get is rainfall. Another interesting fact is that a lot of people look at, if I control it, then it's irrigation. If not, it's just rainfall. But rainfall is your irrigation in a lot of cases. And so understanding how to get your soil right to maintain and have an opportunity to hold on to that water for as long as possible gives you the best chance to make the kind of crop that you're trying to do year in, year out. Heavy drought conditions, if your soil's in better shape, you're more likely to maybe not have your best yields, but have the kind of yield that you'd be. Most important is that you at least were able to make a little money, stay in business, and hope that next year you'll have the better weather to get the kind of crops that'll be will reward you. Another thing that we see is that we do a lot trying to replace labor because we can't find it, and we put in a lot of plants on vegetables are planted, particularly seeded. They're very, very close together. And then we have literally hand hoeing, where we go back out and we take with a hoe every 3 to 4 inches. We're taking one out, depending on how far apart. You may want them 6 inches apart. You may want them 3 inches apart. You may want them, 2 inches apart, depending on what crop you are. And we have to have that, literally lots and lots of people to go through that and thin them out. We overplant and then thin back to the right population. Some of the things we see now is some products that literally are seeing with electric eye going down the row, and they're dropping a material right on that every so many inches. So it's chemical. You can call it chemical thinning. A lot of people don't like the word because chemical has always got a bad connotation, but it could be as easy as a solution, could be as easy as a fertilizer. It could be a lot of different things when we talk about that, but actually taking it out. One person driving one tractor with a very sophisticated unit is going to replace, potentially tens, if not hundreds of people, depending on the size of the field. Also, there's some ways to do it with propane burners, where they'll actually go through there and they'll actually burn that spot and take something out like that. Really, really targeted and focused, or you can have a real nightmare. But it's another thing that we're trying to do, trying not to use, herbicides, or actually just trying to minimize the amount of labor. But having said that, there are some jobs that do not trend towards automation. Some of the ones I've worked with are berries, the actual picking of berries. Uh, we can mechanize the planting. A lot of people will see there with just a few people. We're planting, a few people on the back of a planting machine with a tractor pulling it very slowly, and you have these people across that are actually dropping in a transplant into each one of those holes, and behind it can actually drench it a little bit with a little bit of starter fertilizer, or it's been drenched already before it's placed in there. Anyway, they can, 4 or 5 people can plant what 40 people could do before, when they were having to actually literally stick every hole, plant one, cover it up. It's just improved the efficiency, and everything gets planted the same day and really quickly, so it can get watered back in, get the roots settled, and get that plant started off very, very well. Uh, some fruit picking. I mean, if you get very ripe apricots, peaches. If tried with peaches, canning peaches particularly, and they have had some shaking devices that have put in there and been able to do okay job. But if you're looking at what I call peaches to actually eat the peach, put in the store, put them on the shelf, the bruising and everything that occurs then, when you shake them like that, if they bruise, they're up by that afternoon or same day. They're at the cannery, and they're sliced and diced and put away, and so the bruising doesn't really show up. But if you're getting something, now you're going to send it to a packing house. You're going to take out the culls and everything. You're going to be able to put those just perfect peaches into the grocery store, and with that in mind, you've got to pick them right to be able to do that, and not bruise them, and keep them so that they have a little bit of shelf life. Same thing with apricots and the like. Some vegetables, very, very difficult to get away from harvesting, lettuce, and because sometimes you're basically, and this has still got a lot of hand labor in it, where you actually cut it off. And anybody that's looked at the small, hearts of romaine, basically they're taking all the outside leaves off by hand and just leaving a small, what we call the hearts of romaines, just because they're kind of perfect to make a salad with. They fit everybody's needs better than the big head of romaine. Uh, doesn't fit into your refrigerator as well. I mean, there's just a lot of practical things that we've done. So some of these, they haven't really have anything other than people. So we're not ever going to eliminate the amount of people that takes to harvest in agriculture. So where we can modify, where we can increase efficiencies, we're going to do that. There's one is increasing efficiencies of working the ground, efficiencies of harvesting, increasing efficiencies of weeding, all these things that we're doing. And then we go back to probably the most sophisticated stuff we see, as I started this topic on, is the water technologies we're seeing. And it's the one that's going to lead us probably to better production. But if you have better production and you don't have the people and the labor to actually harvest it, it didn't do us a lot of good. So all of these things have to work together harmoniously, so that the people can understand how we get food to the stores and how we get food to your table. There is a lot involved. We're talking, hopefully through these podcasts, even if you're not a farmer, you can also begin to appreciate how important it is that everything we do to be able to feed a growing world. And this isn't just in California or in the United States, it's all over the world. And we like to think we're very sophisticated and we're getting there, but plants are grown essentially all over the world, and so are crops. And with those, we have to be able to find more and more advances to make a better and better food, and make one that's more nutritious through better fertility and better irrigation, so that we can feed the people that need what we do every day. So that's it for today. I look forward to you listening to the next episode. And until then, stay curious.
Thanks for another absolutely wonderful episode of Agriculture in a Nutshell, Bill. I'm sure that everyone loved what you had to say about the advancements in technology in agriculture and the the mechanization of such. Make sure to leave a like, comment, and subscribe, and always stay curious.